and build product with them. Okay, so today I'm very excited to share overall my thoughts about a very interesting topic called multimodal RAG. So with that, let me share my screen. So uh, all the setup that Abhinami has discussed with you, I'm sure before this session you might have also worked on some of the Vertex AI services. But in case if there is someone in this session who is doing this for a first time, you need to do some additional stuff to make sure that you are able to run this notebook correctly. Suppose you are on this home page of your GCP project. You can go here and type Vertex AI. Okay, so when you type to Vertex AI, uh, if you are using it for a first time in your project, there is an option called enable all recommended APIs. Okay, so please do that so that you will not face any errors while running this notebook. Billing account is already set up. You will enable API from here. There is one chance that you may encounter error, and if it comes, I'll tell you before the hand. It could be some IAM issues. If you have newly created a project, your default service account should have Vertex AI admin access. Okay, so if you have not done that, if error encounters, you just make sure that you have a default permissions to do this. Now let's get started with our today's session. um so okay. Uh, so though we call it as a Q&A app, we'll be more focusing on the core part of it, not the full stack apps aspects of it. It's more about understanding the power of Gemini Pro and how can you get better results than conventional RAGs, and how can we leverage multimodal features. Okay, uh, people who are uh, very new to this concept of RAG. So I'll just give you a very, very short, high level introduction of this. So RAG stands for Retrieval Augment Generation. Okay. So first thing people will ask, like, why you need a RAG? What is so special about it? Aren't my LLMs smart enough to answer everything? Okay, so the foundation models that you get, okay, those are called as uh, uh, any foundation model that you use. So in a layman terms, we call it ask me anything kind of a model, right? So these foundation models are not trained on your private data, right? Suppose you have some problem, private documents which are not shared outside, and you want to perform some Q&A applications and all that, right? How can LLM understand what data that you have, because it is not trained on that. So you can ask general questions to LLM and get your answer, but if you really want to make a value out of LLM applications, like intra knowledge Q&A and all that, where you have private documents not shared with LLM during the training time, you don't want to tune an LLM also, but want to build something very fast, then RAG will come into the picture. So it has clearly, two sections. Okay, as you can see that there is a part called retrieval and there is a part called synthesis. So a first step of RAG is like all the documents that you have, you split them into smaller chunks and then use some embedding techniques and convert that unstructured uh, data into some structured manner and save it into an any data source of your choice. Once this database, a vector database, is ready, then it's a matter of how intelligently you are retrieving this data. So first part is get the relevant chunk out from your vector data set and then use an LLM for synthesis. Synthesis means your answer generation part. Okay, so this is the fundamental of RAG. Uh, this is an offline process or one-time process. You can say that you can have your vector database ready. One time, once it is ready, then you can use it at the time of querying and consumptions. Okay, so RAG gaining popularity because some of very interesting other applications like increase accuracy and relevance, because in an LLM, instead of asking any open-ended question, now you are bringing some context, so that the answer relevancy is definitely better than any open-ended question. Reduce hallucinations. Okay, if you're asking some questions which are related to your private document, if ask me anything foundation model, if you ask question, probably if it hasn't seen those documents in a training data, it may hallucinate. But in order to make sure that all the answers that you are getting from LLM are correct, there are no hallucination, RAG is a way to go for you. Okay, greater adaptability and enhance user experience, because now you can also justify from where the answers are coming. You can actually do citations. So very interesting use cases can be developed on the top of it. So these are the the obvious advantages of using RAG workflows. Now the question comes as, then why multimodal? Like if everything is going really really well so far, uh, what can I get? Like why I should go for these kind of an complex racks, right? So why multimodal? So you'll understand that today's is a data rich world, right? So the documents that you might be having with you, uh, they will be having very complex information into it. Like information could be in the form of text, it could be in the form of images, or it could be form of videos, animation, so many stuff into those documents, right? So just understanding the text part of it give you very limited accurate results and all that stuff. Now you can imagine, suppose you have some financial documents, uh, financial results and all that, where complex graph and charts are present in a document. There could be complex tables which are there, right? So if you want to extract an information which is present inside that image, just traditional text based RAG will not serve a purpose for you, right? So multimodal will help you to take care of unlocking a deeper understanding of information landscape what your documents are having. So now the question comes in, yeah, definitely, like I will be working on complex documents, like uh, uh, user manuals in manufacturing industries, or data sets, financial documents and all that. How can I leverage this into building a RAG applications? So there are two options of doing multimodal RAG, and there is a slight difference between it. I would like to spend some time here, so that the idea is exactly clear in everybody's mind. It could get confusing in the beginning, but just try to understand. There is a difference between multimodal embeddings and multimodal LLM. Okay, so try to understand that. What you can do is, so what is multimodal embeddings? So multimodal embeddings is a model, we call it as a multimodal embedding models. You can get a pre-trained multimodal embedding model, and the beauty of this model is, you can pass text to it, you can pass image to it, you can pass video to it. It will generate a vector, and that vector is of a similar size. So the multimodal embedding will not care about what you are passing into, but eventually, if you see that the embedding, all the vectors which are generated from text, image or videos, they would be in a same vector space, right? So if you can see that, this can be, you can see that the image embedding vector and text embedding vector are in same semantic space, right? What does that mean? It says that once you have text, images or everything, when you pass it through an embedding model, after that all the vectors you can consider, like in similar stuff. After having that vector, it is hard for you to distinguish between those two. So they will be in the same semantic space. It's not that this is a imaging space and this is a text space, right? So bring everything into a similar kind of embedding space. So this is called multimodal embedding. Okay, and uh, try to understand how these models are trained also. So these models are typically trained by giving a text and image together also. For example, this is a text, this is an image, this is a text, and they are trained together to produce a vector to make sure that the understanding is correct. So a very popular applications of these multimodal embeddings, you can see something like this, where you can have text to image search kind of stuff. So for example, you can type here like in black table, and what is the nearest search that you can see for this. So text to image, you can say black table. See this. Now what you are doing is you have a text. Okay, you applied two multimodal embeddings, you got some vectors, you had some images in your repo, you created a vector. Now in a vector space you are finding all these nearest neighbors for this kind of index, right? So these kind of an applications, multimodal embeddings would be very helpful for you to do that. uh, it's not that this cannot be leveraged in the RAG applications also. I have seen people using multimodal embeddings within a RAG applications also. And how they do that? They do it in this fashion, like use multimodal embeddings to embed text and images. So whatever document corpus that you have, you use multimodal embedding for the textual part of it, for image part of it. So you have a vector, and then retrieve both using similarity search. Means what? You pass those, create a vector, insert it into a data store, and then what you do is pass both retrieve raw image and text tag to multimodal LM to answer the questions. Means what? What you are doing is you are using first as a multimodal embedding model to generate vectors, then use this to retrieve by using nearest neighbor or whatever algorithm that you have. And then what you can do is for answer generation, you can use multimodal LLM, right? So whatever that you retrieved, you can use it for answer generation. There is another way by which people do a RAG. And if you see a difference here, what they say is first we will use multimodal LLM to generate the text summaries of an image. So it is exactly opposite to what we did in the first part. In the first part, we use multimodal embeddings first, brought everything in a same vector space, apply similarity search. From that, got the raw things, and use multimodal embedding for synthesis. Here, what we can do is we can use multimodal LLM at a first stage. Now they understand multimodal LLM means the advantage here is suppose you have an image, and if you have a multimodal embedding model, it's not just getting an embedding out of it. You can actually ask, or you can actually leverage multimodal features of this model to get the text summaries out of HML. This summaries is means what? Now the advantage is because this is kind of an prompt engineering. Like if you are building an application for financial domain, you can pass an image to this multimodal model, and you can actually prompt that model saying that, hey, consider yourself as a financial expert. This is an image I'm giving you. You describe what is going on in an image, so that now LLM understand from what perspective I need to see this image, and then it will give you an answer. So what you're doing is you're leveraging multimodal LLM and then get a text summaries out of it. Now you have all text together. Then what you can do is you can just use normal embedding and then embed that and then pass chunks to LLM for answer synthesis. So these are the two different ways of doing it. I'm not saying use for this and what is advantages, what is the, it's all empirical. There is no rule of thumb or there is no one fit for everything, but you can clearly see a difference, where you have more flexibility or for your use cases what things are working out. I personally liked the second approach, with a very clear advantage of giving me little bit extra flexibility at this point number one, where I can actually do some prompt engineering. Here in multimodal embedding, you have no choice. Okay, you are just uh, using some pre-trained embedding model, obviously in the first go, get an embedding and do a vector search on the top of it. But here at a first place, I'm generating and bringing everything into a text format, and then using a traditional rag, and then do the stuff. It's complete open. The beauty of all this stuff is you have a full liberty to play with. uh, you can make a combo of two as well. Okay, so full flexibility. I'll just I'll not spend more time on it, but I hope you got the difference between the two. Now I'm going to discuss a very interesting new philosophy of multi-vector retrieval. Now understand that you know rag is not new now, and people have built basic rags, and they got, it's a very active research area, and every now and then people are recommending some improvements on the state of the art stuff. So recently on a lang chain, we saw that now it supports a multi-vector retrieval, which again open up a lot of advantages for you in order to build very amazing applications in a say. So what do you mean by multi-retrieve, multi-vector retrieval? It's not just a vector retrieval, it's multi-vector retrieval. So if you see here, this is what we actually gonna implement in this code lab also. Uh, Instead of a simple vector store, now we will be leveraging multi-vector retrieval. What does that mean? It says that now you can actually have uh, you know you can have images, you can have tables, you can have text. This LLM, the brain that you are seeing, it's a multimodal LLM like Gemini Pro, okay, or Gemini Pro Vision in that case. You can use these LLMs to get summary of this image. Summary means you can actually do any prompt engineering. You can ask to describe what is going on in image. You can ask, do an OCR on the image, extract all text from image. All flexibility is for you, but giving an image as an input, you are actually creating a summary out of it. From a text, you are creating a summary out of it, and from a tables, you are also creating summary out of it. Now what you're doing is, once now if you see all those summaries, this is now in a text format. So what you can do is you can now apply a normal embedding model and put those into a vector store. Along with that, what addition the multi-vector retrieval provides you is a data store. So for this summary, what was the raw image? For this summary, what was the raw table? For this summary, what was the raw text? That is also available. Now, why are we doing this? Now, the beauty is that for an answer generation, you have multiple options ready. If you see that the latest development and how the world is moving towards bigger and bigger context lengths, right? So now your foundation models, the latest LLMs, they have a bigger context, bigger token limits, and all that. If you see very simple applications of the rack, people were using document chunks, because you retrieve some chunks, and there are always a struggle between top two documents, top three chunks, because they directly impact on the token length of your context and all that. But with now the developments like bigger models like Gemini and all that, you really rarely worry about the token length, because they support like million token lengths and all that. So the beauty of this multi-vector retrieval is, now you can ask a question in an English, you do an embedding. From this vector stores, you can find your nearest neighbor, the closest head. Once you know what is the closest head, you can actually get back the original raw documents out of it. And these raw documents now can be used by multimodal LLMs or LLMs with larger token limits for an answer generation. What is an advantage of this is? The advantage of this is, now you have a full document available for synthesis. So there is no risk of missing uh, context, or the important information getting split into multiple chunks and all that stuff. So full idea given to an LLM for answer generation stuff. Again, this is not the only way, but I really liked it. And in today's code lab, we will be leveraging this multi-vector retrieval. So far, I gave you a full background to make sure that when we run the code, you will be familiar with the terms, you will understand what we are doing, and it would be easier for you. So enough of theory, I believe. So what you will build here is, so when we start actually writing the code, we will do a data loading through langchain. We'll do document loaders. We'll take some sample documents. Then we generate text summaries using Gemini Pro. Then we use image summaries using Gemini Pro Vision. Then we use multi-vector retrieval Google text embedding, use Chroma DB as a vector store, and then develop multimodal rank for the question answering. So if you see this flow and a diagram that I'm showing you, see this? This is a document. We have images. We will have text. We'll use this Gemini for text, Gemini Pro for vision, generate their summaries, insert summaries into vector store along with your raw data, and then leverage this multi-vector retrieval for our Q&A chains. So this is all what we're gonna do in this code lab. So I will take a 30-second pause here to make sure that we are all in sync, and just give me thumbs up if you are all ready to run code along with me. Perfect. Thank you so much for your responses. Let's get back to our code lab. So okay, before you begin, I think Abhirami has explained you. Go to Google Console. Make sure that you select your project. Make sure billing is enabled. Make sure all recommended APIs are enabled. And now you can open Colab, or if you are familiar, you can also run this notebook from your Vertex AI notebooks also. With interest of time, right now uh, I'm not going to cover how to create a notebook instance and all that, but this can be executed in any of the Colab. So open Colab with me, and then we'll get started with this. So this Colab uses Vertex AI for Python and LangChain, uh, and this has been adopted, from a repo. Full code is available on this GitHub repo also. So with that, let's get started. So
Just
first,
one, sorry to interrupt,
yeah,
Bhushan. All the developers who are trying to get hands-on right here, please make sure you open the collab.sandbox.google.com link. I've pinned the link as well.
mhm,
Open that from your uh, same Chrome browser where you have Google Cloud logged in with your billing account, right?
yeah,
Because remember, that's where you have your active project and billing account,
yeah,
and that's where you have enabled that API, Vertex AI API. If you have not enabled it, go back to Google Cloud Console, search for Vertex AI, and enable just Vertex AI API, and then come back to collab.sandbox.google.com because you want to have that in the same account as your GCP
yeah.
console.
Yeah,
Go ahead,
thanks,
Bhushan.
Rami. And we have this small piece of code here, which will anyways, even if it is on your different Colab tabs and everything, it will ask you for authentication. So the same credentials that you use for GCP project, you should give the authentication. I'll show you that step for you. Okay. So with that, I assume everybody is ready with a blank collab. What you need to do is you need to, on a first sale of your collab, just copy this. And these are the dependencies that we have. So first of all, just run this and install all the packages that are needed for uh, developing this. It will take some time, so let it install all.
Excuse me,
Yeah,
can you please show it from the opening of the Jupyter lab, that is Colab?
yeah. Abhirami had shared you a link. Can you?
Yes,
Yeah.
I just opened Welcome to Colab. After that, I just missed out because of network outage.
Okay. Mm, just a minute. So, when you sign into Google, you should like mm, how you can open a collab normally.
You just have to create a new notebook from there, Krishna.
Yeah,
Go to Collab and you should see the file menu. Just click that and do new notebook. That's it.
yeah,
And then copy paste the first two lines, just like he did.
yeah. And just here we are so far. We are just installing the required packages.
Yeah.
Okay, thank you for helping.
Yeah,
Yeah. Going forward for all the questions, please use the chat, folks. Thank you. Go ahead, Bush.
we are still installing the package. Just a minute. Okay. So if you see this pips dependency resolver, that is okay. This is not a blocker. Few packages has version uh, issues, but for us, you don't have to bother about. So once you execute this step, uh, do not forget to restart your kernel in order to make sure that those packages will be consumed correctly. If you forgot to restart a kernel in the other next steps of this code lab, you may face some issues, right? So you go to runtime and you can just say that restart the session. This is important, participants, because I get many messages like, we are getting errors because of package not found and all that. So make sure that after installing all these packages, you have done a kernel restart. Okay, now let's get started. So if you go back to your code lab, the next option here is, you need to provide your project ID. So whatever your project ID, that you should put the name of that project ID here. Uh, Region, keep it as a US central one, and then we will be doing an authentication to make sure that the correct person is actually running this notebook. So in this notebook, I'm using the project ID. This is my project ID. Please note that project name and project IDs are two different things. So if you are on your project, so if you go here, if you click, so you will have name and ID. In my case, my project ID and project name is same. This may not be the case in in your project. So I'm asking you to copy your project ID that you are using. So here, just give a name, your project ID, keep region as a US Central 1, and then execute this cell. When you execute this cell, it will ask you for an authentication. So here is a step where it is making sure that uh, the same person who is having access to the project. So now in this case, I'm the owner of this project, and I'm just giving authentication and saying that continue. So everyone who is using Colab for running this, they have to do this step. And once you do that, authentication is done. So now you have all rights to consume the billing of your projects and all that. So very first thing that we have to do is initialization of your Vertex AI with your project ID and all that. Just run this. This is initialization phase. Awesome. Now, before we actually start building our RAG application, we need some sample data. So what this notebook is doing is, from cloud storage, it is downloading a zip file. Then it is extracting that zip file and keep our data ready for that. So where we are right now in our notebook is prepare and load data. So just copy these cells into uh, your code lab. So first cell here will perform you know data download for you, and then it will prepare data for you. So just come here and do this. So once you execute this cell, if you after executing this cell, if you open this box, the symbol here called files in your code lab, you should see this cj.zip zip is now downloaded and also extracted here. When you click on that folder, you will see that there is a cj.pdf and some figures. So these are some images which we're going to use for a multimodal rack. So some figures, a pdf file which has some text will get downloaded. Here is a step now when you will use some data loader. So it's for LangChain community document loaders. The PDF file that we have, we will be more focused on the text present in this PDF. So you will get all the text in this PDF. The beauty of using this LangChain stuff is you don't have to write your own custom code to extract text out of it and all that. So when you run this cell, you'll see that every page, all the text that we are showing here, and the tables into this. So if you see texts, you know you'll see this. So this is the text of 0. If you open this cj dot pdf, uh, then let's see if I have that. Okay, now if you open this cj.pdf, you can see that this document has how many, close to 21 pages into this cj.pdf. Now we have just done a document loader and extracted. This is a first file. So of before executing this, if you go back to your code lab, len of text, right? So if you see this, and if you run uh, after your text.0, when you run this code, you'll see that it's showing 21. So what is happening so far is we have taken that 21 pages PDF, and we have extracted all the text from that. So there are 21. The length of this text is 21, and you have a raw text that is extracted. And for that, we have leveraged the LangChain document loaders. um, from the code lag perspective, we everyone is on page number 5, and after that the actual multimodal stuff, the beauty will get started. So before I go to step number 6, I will take uh, a short pause. Just let me know how many of you are with me. Everybody all good? Amazing. Thank you so much for your feedback. Let me go back to my code lab now. So now Uh, yeah. So what I will do next is, uh, I would request you to copy these two cells. It will take some time to execute. So let us execute and then I'll explain the code for you. Okay. So I'm here. Now this is a time for us. If you see this notebook, as I discussed, if you remember this stuff, what are we doing is from the text part of it. Now this, if you're saying this ping brain LLM, so here is a job. So we are at this particular step. We have a document. We have taken the text out of it, and in that zip, we already have separated images for you. Okay. For this code lab right now, we are not focusing much on the table. So now you have images, now you have text. So this is an LLM, and we're going to use this LLM to generate the summaries out of it. So first what we'll do is we'll generate summaries for the text, and then we'll use summaries for an images. So to get summaries of a text, we'll use Gemini Pro. For generating summaries of images, we'll be using Gemini Pro Vision. Okay. So the next steps in the code lab are doing this stuff. So let's go back to this. First, copy this and import all the required packages. If you have done kernel restart after installing the packages, and when you run this, you should not get any error for this. Okay, so execute this. Now, come to the next part of it. So if I'm here, if you see this, this is a function that I'm calling called generate text summaries. What I'm passing to that is a text. So if you remember, what is this text is your 21 pages that you extracted, right? So if you see here, this is the len of text 21, and this is the text that is present on the first page of that PDF. So you have this with you. What are we going to do here is, now we will take that one by one. So there would be uh, there would there would be a loop going on. You will see there, in that loop you will use it one by one. So I'll come to that. uh, See this. So first, this is the prompt. If you remember in the beginning of this discussion, I'm telling you that the advantage here is now you can say that you are an assistant, task with summarizing rules or the text that are given for you and optimization for this way. So this is a prompt. What model that we're gonna use for this task is we're gonna use a Gemini uh, Pro model, and what you have is text summaries and table summaries. See this. Here you are saying that summarize chain by batch, and this is a text. So if you see this, in our case we do not have tables. So in the batch mode, we're going to pass this text as like 21 as a length, and what are we going to get is a text summary from this model. So if you see this, we finally we'll call this called generate text summaries. We will pass text. Tables is blank in our case, but you can have a special treatment for tables if you have. And then you say summarize text is equal to true. So when you pass this function called generate text summaries, this is the actual function that we have used. It will use this prompt. This is a place for you to do all the customization and playing. The model selection is done as in Gemini Pro. We will be using default summarization chain in a batch mode here, and we'll pass this batch of text, and it will generate you the text summaries. So full control on you. This is a place where you can play. This is a place where you can choose the model. Eventually, once you run this step, the way you have a text, similarly you have a corresponding text summaries also with you. So go to your uh, code lab again, just run this, and for all those 21 pages you will have their corresponding text summaries ready with you. Now, while executing this step, if you encounter an error of permission denied, okay, the only reason that you don't get a permission error is because you do not have sufficient IAM rights. So two things that you need to do: you as a user, you have to have, or sufficient rights. So for sake of simplicity, I'll recommend you that you go for Vertex AI admin. So Vertex AI admin role should be given to default service account, and it should be given to the user of this. So otherwise, you may encounter this error of permission issues. If not, everything is fine. You can see that the text summary is of zero. So this is a summary that we're gonna get. Now this PDF, already have very small text out of it, but now you can understand that, the summaries will come. Like if it is a text heavy page, you'll get a small summarization of that available. Okay. Uh, where we are so far, we have all text, we have used LLM, and we have generated the text summaries. Why we are generating text summaries? Because when we ask a question, we will get a hit on our vector store on a summary. So rather than breaking a documents and making a chunks out of it and doing the chunks of every small document, what we are doing is, okay, I have a page, I have its summary, and I'll have a hit on a summary. And once I have a hit on summary, then I can retrieve entire page or whatever the requirement that we have. So if I go here, we finished step number 6, where we have extracted um, text summaries. We can go to step number 7. What are we going to do on step number 7 is uh, we're gonna do exactly same stuff, but now on the images. So if you see this again, by the time it's execute, what I will recommend is you copy this cell, okay, keep it for execution, because it will take some time, and meanwhile I'll explain you the code what is happening. So if you copy the two cells on step number 7, and if you could start your execution, it will take some times, because uh, it's image vision pro, so it will take some time to execute on all the images that we have. But I'll explain you what is happening in the code. So ideally, the way we have text extracted from every page of a PDF, now we have all sets of images. You will see that figure 1, 2, 3, 4. These are the figures extracted from our documents already. We will take those one by one, and then we'll extract the summaries. So let me go back to the code for you here. So in this code, again, there are some utilities written to encode an image into some base 64 format. It is required to call a Gemini Pro Vision model. So that's a utility, and we'll be using that. But very interesting stuff is, what model are we going to use here is a Gemini Pro Vision now. Image in a base 64 format, and the prompt. So generate image summary will pass image in base 64 format. This is a function that will use to encode an image, and the prompt that we want to use, right? So here is in generate image summary, the path of all images that we have. This is a prompt that we have designed, like you are an assistant. And if you remember in the beginning of this call, I I discussed about advantage of going with this path compared to starting with multimodal embedding is, here you have a flexibility to do some prompt engineering on, you know what that you are looking for those images, because you are the end user, you know what kind of a documents you have, you know where to focus on, so you can tell that where to look into and all that. Who is asking you? So this is a prompt that will be used by Gemini Pro Vision. You will read those images one by one, encode them, and pass this to this, and then similarly you will get a image summaries, the length of image summaries, and all that stuff. So if you go here, you'll see that you executed this prompt, and now you can see that you have length of summaries, image summaries, and here you are seeing the summary of an image. Now understand it. The image shows the line chart of revenue and all that. Now this is very interesting. So when we actually fire some queries on this data, you will actually appreciate why we did this step before compared to just multimodal embedding. Because now you're, if you see the first summary, it is understanding. So all these figures are have some charts and drawings and everything, but now your model is understanding what this image is showing. It's showing that it has a line chart, there are three lines present, and what things are happening and all that stuff. Very interesting. So far, if you see where we are, we started from here, we generated text summaries, we generated image summaries, and now the next step that we're going to do is put everything into multi-vector retrieval. Okay, multi-vector retrieval means we will insert summary as well as its raw document. Okay, why we are going to do this? Because now for answer synthesis we have, I want to keep that option open, that even for synthesis, if I want to use a heavy multimodal model, I want to have an access of entire document. I may not leverage this in this code lab, but I wanted to keep that option open, that you are free to experiment around that. Okay, so far, now we are at step number 8. Now at this step number 8, uh, now this will not take much time for you to execute. So let me explain you what is happening here first, and then you can run this. So first cell is all about importing the required stuff, this multi-vector retrieval. I think I explained you what multi-vector retrieval is. We'll use some local data vector store as in Chroma data store. Okay, so I'm just writing one function called create multi-vector retrieval. See this multi-vector retrieval, and from its input parameters, you will understand what is going on. So first, I need a vector store, that where I want to put all that stuff. Always keep eye on this diagram. I need a vector store. Then what I need is, I want text summaries and their corresponding raw text. I need table summaries and their corresponding raw tables. I need image summaries and their corresponding raw images. In our examples, we are not doing with the tables, but it also supports that. Okay, so what I'm doing in this function is I'm saying that use LangChain multi-vector retrieval. What vector store I'm going to use is the vector store that I'm going to pass. So this vector store, I'm passing it, and we will be using ChromaDB for that. Uh, so see this. What you're doing is, if text may add documents. So in a given retrieval that we have defined, we will insert text summaries and text. If you have tables there, you will, in the same retrieval, you will insert tables. In the same retrieval, you will insert images and summaries. We have created a vector store called Chroma, and again, there is no binding and that you have to use Chroma. We have limited time, but you can anyway go LangChain page and see all the different vector stores that it supports. So we are going within Chroma as a local data store here. So you create vector store. Now, in order to insert that, this is a place where the embeddings will come into the picture. So we are going with a gecko embedding. So these are the text embedding. So if you see this image, you have summaries and everything, but in order to put that into a vector format, you have to mention what embedding model that you are using, right? So that is important. So if you come here now, you are saying that I'm creating a vector store. What vector store I'm creating? Chroma. This is the name of that vector store, and what embedding function I'm going to use. So we are using Vertex AI model called Gecko embedding model. Now this vector store you have defined. Here you are defining a function called create multi-vector. You are passing that vector store, and you are passing text summary is raw text, table summary is raw table, image summaries and raw stuff. Everything is in place. Eventually, you create your retrieval. So you're calling a function called create multi-vector retrieval. You pass these parameters, and what you get is a retrieval ready. So these are all, LangChain provided functions. So copy this step. You will see that this is executed, and Just run this. You're not doing anything else. It is just an initialization of this. What it will do is it will create a retrieval. It is doing an insertion operation, so it may take some time, but it is pretty fast. Okay. At that time, what you have so far is you have a retrieval ready. So in this diagram now, we are here now. Now your retrieval is also ready. Now what is the last thing? Now the last thing pending here is now you query to this data store and get a content out and do your.
Bhushan, sorry to interrupt
Yeah,
one more time.
yeah.
Um, can you just show the point in the in the notebook where you wanted them to set their project ID environment variable?
Oh, sure.
Looks like some of them
Yeah,
haven't done it.
yeah, sure. So it is at a very early stage in the notebook. So if you see this, it's a kind of a first step. Okay. So after you do all your installations, no, here is a place. So this is your first step. Like enter your project ID here. If you're referring to code lab, you should go to your step number two, step number one. So your step one in this code lab starts with installation. So you install all the required packages, then you restart your kernel, and then you start fresh with providing the project ID. So here in the code lab, I have just given two blank codes. Here you need to enter your project ID.
All right, thanks, Bhushan. You can go back to the explanation where you were. Sorry.
No, this is perfectly fine. So so we were here. Okay. So what we have done so far is we have built this multi-vector retrieval. Okay. So everything is ready. Now it is a time to leverage that. Now it is time to ask a question, get the raw data out of it, and then use an LLM for question and answering. Okay. So this is a heart. Okay. So RAG will start from here. So far this all, we prepared what we wanted to do, all that stuff. Where we are at step number 9 and building a RAG now. Okay. So here, there are some utility functions that we're gonna use. For example, this is a function that I'll use to plot the image, because when we are generating an answer, I want to show you from which image the answer is generated. Uh, then I'm just using another utility function to check that, the retrieve whatever the documents that I'm retrieving, is it coming from image or it is coming from text and all that. So you can see these functions like whether this is a base 64 format correct, whether it's an image data or not, uh, then resize an image because I want to display that image. So, and then split image and text type. Okay, so this function is important, uh, which actually splits encoded images and text. I'll come to this point. For now, just consider those are utility functions that we're going to use in order to display uh, the results. There is a function called image prompt function. So this is the place where we are actually asking about, see this, you will be given mix of text and tables and images, usually a chart. This is an information provided by, investment advice related to these things. And then eventually you have to, create an answer out of it. Okay. This is the prompt, the text message prompt that is helpful for us for the answer synthesis. So because we're going to use this, I have defined those in the beginning, but when we backtrack it, you will understand what is going on. So this last part, will have a reference to all the stuff that we will be using. Okay. Now this is a typical LangChain way of defining these things. You will see uh, uh, a lot of high level functions, and you don't have to do everything on your own. Very nice and neat way of representing the things. Okay, what is saying that define a multimodal rack chain. Why it is chain? Because you have to do step by step stuff. So it's a multimodal rack chain function. So what we are doing is, first of all, we are saying that what model that we want to use. So we're saying that we're going to use uh, Gemini Pro Vision as a model, as a best model. Uh, then we are saying that uh, we will be we will be using retrieval. Okay, so we have chosen a model for answer generation. From where I should bring a data? I should bring a data from this retrieval. Remember, we have defined our retrieval in the previous step. So if you remember this, this is the, you know, retrieve multimodal, create multimodal retrieval. So we have defined that retrieval that we will pass as an parameter to this, the same retrieval that we defined in the previous step. So you have to tell LangChain that what model that you're going to use, what retrieval that you're going to use, what pre-processing steps that you're going to use, and eventually what is your prompt for extracting or answer generation prompt, and a structured output parser, which is again defined in the LangChain. Okay, so this is a way where you will define the stuff, and then you'll see that create rack chain. So this is the rack which that we are defining. So if you remember that, we are calling this function called multimodal rack chain. This is the multimodal rack chain function. We are passing the retrieval that we defined in a previous step. In this step, we are choosing the model. In this step, we are saying that what prompt function that we have to use, and then we'll start execution of this. Okay, so not yet started querying it, but we are just defining the steps. Okay, so nothing very special so far. We, if you see where the code is, yeah, so far we were here. Okay, we have just created, we just called this function called create vector, I guess. This is a time where we'll define our utility functions. Nothing we are executing. I'm just defining what prompt I want to use. And then I'm saying that what is my multimodal rack chain? This is my rack chain. This is a model I have to use. Uh, this is the pre-processing. This is a model function. And here is a step where you are actually defining your rack. Okay. Here the real beauty will get started. So I'm very curious to see how outcome that it is coming. I'm not saying that my answer will be consistent always, but let me hope that we'll get the best answers and all that. It may, your answers may vary a little bit, but let's see. So the question that we are asking is, what are EV and NTV? NTV growth of MongoDB, Cloudflare, and Datadog. So when I ask this question, if you see this, what I'm doing is I'm not even using any question answer chain. I'm not actually doing Q&A here. What I'm saying is, I'm just saying that retrieve multimodal return. I'm saying that get relevant document first. So if you again read this, for my query, give me a raw documents. I'm just asking you, give me the relevant documents. So when I fire a query, I'll get raw documents coming out, and that could be a text, that could be an image, that could be anything. Okay, based on my question, it will also get embedded, and from this vector store, with the summaries that I have, it will return me the matching documents. Please understand that matching documents from this data store, it could be image or it could be anything. So when I ask query, this query gets embedded. If you remember, when we defined retrieval, here we have defined our text embedding model. When I run it, it will return me the relevant documents based on my queries. It will take some time, but let's see how it goes. See this? Now If you carefully see this, you'll see that, oh, what kind of a documents are this? So this that you are seeing, so this is your base 64 embedded format image. So the best suitable that you got from this retrieval is this. So this is actually an image, but it is in a base 64 encoded format. This is the second document that you have, and this is the third document that you get, and this is the fourth, and fourth one is again an image. So when you run this, you'll see that this is the first image. Look at this. So based on your question, that's the beauty of multimodal RAG, that I asked this question. I want to compare this EM and V growth and everything for MongoDB and all that. This information was present in a table in some image format, and it has very rightly taken this image in. Now it's time to synthesis part of it. Now in the synthesis part of it, what I'll do is I'll use chain. And if you remember, what model that we used for this is a uh, provision model. So when I pass this query, these images will go as in context to this, and you will see, for a same query, the next steps. Again, if I take the reference of this diagram, so far I have just seen raw documents. What is not shown in this diagram is the last part of doing Q&A, because this is LangChain document only talks about retrieval. We're gonna leverage this retrieval. Very last part remaining is I have a context now. I'll pass a question, and when I execute this, I actually get the answer of my question. So this is the last part called as answer synthesis, and look how beautifully it has taken. So if you see the questions, it talks about only MongoDB, Cloudflare, and data log. So if you see this image from where the answer has got, talk it is talking about so many companies, and it has given this as an input for me. So that's the multimodal rack for you. uh, you have access to this notebook. I think this is what I have to cover in today's session. I hope you like it, and thank you so much. Despite of a semi-final of World Cup, you attended this session. I know everybody wants to catch up with the score and a match. Uh, I'm always happy to answer any questions. You can submit it offline, and please share your feedback with Abhirami. Uh, and hope we'll get soon with you.
That was great, Bhushan. Just a couple of things. A lot of folks had questions about the file that you're using for image and PDF. And I
Mhm.
know because this is a trial account, the trust for this account and also which also correlates with the size of data that you can pass in. Typically, that's not how it works in your production account or in your
Yeah.
personal credits. You wouldn't face this issue just because it's a trial account created on a large scale for so many folks. It's
Yeah.
it's kept at that limit, so that is why you're seeing quarter limit exceeded error.
Mhm.
Make sure you're taking small files like 1 page or something similar to test it out. And images, some of you had questions where dot/cj, you didn't know what to add there, and or you probably got error in that line. That's because Bhushan was using images within that folder that where his code actually resides. You put some image of your choice in there and you can test it.
Yes. That's
Yeah,
correct.
or any PDF or anything that you're testing. The whole point is for you to understand the concept of multimodality in embeddings. And embeddings typically means that you convert your data in any form into vectors or mathematical format that Bhushan was talking about. So this was really great for us because now previously we did text-based searches with RAG, we did vector search and all that, but now you can, what you need to know is, even if you have a bunch of images in your cloud storage, right, and then you're building a Q&A app where someone says, I want to search for yellow shoes. Now you don't have any description for the images, but you just have images. You convert both into embeddings. using this multimodal embeddings API, you should be able to compare the text yellow shoes against the yellow shoes image, and it'll bring out everything that's possibly considered a match to it. So that's phenomenal, and that's transformative in the world of AI and particularly vector search, because now we'd be able to bring all formats of data in the same platform, right? Like you in the same platform is the wrong word. Probably you should say vector space is the word you used, Bhushan,
Yep.
or plane of vectors. So that is, yeah, that's a dream come true for a lot of data related areas. So, or applications. So I hope you all enjoyed this discussion. Bhushan, there's one ask for repeating steps 7 and 8. If you can just talk about it, that'll be really great. Just summarize it high level. You don't have to go through the code like you did. Just
Yeah.
summarize it at a high level.
Yeah. So it's very similar. Like as in steps in step three, what we did is generate. So in a very simple format is in step number three, we use a sequential call that we use in a batch mode to generate text summaries. In step number in step number uh, it's step number 7, we will be using, so we'll use Gemini Pro. We have a prompt, so for all images that you have, you will run it in a loop and saying that for this image, would you describe what is happening in this image, so we'll get a text out of it. So if you have 10 images, then you have 10 text summaries ready for this. So in step 6 we got the text summaries. In step number 7 we got image summaries, and in step number 8 we put insert everything into a vector store. So again, coming into this diagram, in step 6 we did text summaries, in step 7 we did image summaries, in text 8 we put, if you see there is a Python code called dot insert, so we are inserting those into this vector store. That's how it is. Yeah.
Thanks, Bhushan.
Yeah.
This
There
is
are,
a,
yeah.
sorry, go on, go on.
Yeah, if there are more questions, I'm happy to answer them offline as well. Yeah.
Yeah. Also, Bhushan's LinkedIn, I'll share along with the details, the video recording and everything that will be sent over tomorrow in email. So you'll get everything in your email, and also about certificate link for the entire. This is the last session for the season, and we finished it in style as usual. I really enjoyed your session, Bhushan. It was very informative. I should tell you, and the engagement from start to the end was phenomenal, and I really liked how controlled and engaged you were throughout the session. So thanks a lot for that. And Leads, thank you so much for being there. And all the good questions from the participants. I see a lot of questions about project ID not being sent. So we've answered a few. If your questions were missed, apologies for that. But feel free to use the Discord channel for discussions after the session. And feel free to watch the recording for repeat of any step that you may have missed. Also about submission of results. This session, there is no result submission process. For the previous sessions, not even the last one. Last session also, we had no submission. Totally, you have 7 sessions for which you can submit results. 5 or more will be eligible for the top tier cert. 3 or more will be eligible for 3 to 5 will be eligible. 3 to 4 will be eligible for intermediate, and 1 or 2 will be eligible for having attended the season. So that's pretty much it. You'll get all the details in email as well. Ankit, I know you have your hand up. If you have something to
Yeah,
be,
yeah,
will be
yeah,
the
ma'am.
last question.
I am waiting for your last word. I have asked one question.
Go on.
First of all, thank you, sir, for nice presentation. And one query I am trying to ask that if I implement this model on the finance sector, like take any finance sector and implement on that part, it will work or not? Is it just
Yeah, it will definitely work. Like, I'm not saying any issues. Why not? Rather, that's what my intention here is, because you are using multimodal LLM in the first step rather than multimodal embeddings. As I'm talking about, it gives you an opportunity to write your own prompt. As you see in this code also, you can say that, hey LLM, consider yourself as a financial expert. I'm giving you this kind of a document. You are expected to extract blah blah blah, right? So you can actually, instead of saying that, do this. so that you can get what you want from those images coming up, so that the quality of your answers will be definitely better, rather than just saying that this is an image and you describe what is there in an image. So that context, as you mentioned about, can it work for financial? Definitely, because you know what you are looking for. So it is certainly better than any foundation pre-built multi-modal embedding model, right? Because here you get ability to play with your prompts while getting text content out of it. Yeah.
Yeah. So that, but the thing is that when the data set is very big, matlab when we handle the like approx 20 25 years of, like taken a simple example, just like TCS data set, take a direct data from the yahoofinance.com and
Yeah.
implement that model. It will work or not? I just,
It will
because my,
definitely, you can see that, even there are so many stuff available on exactly the same problem that you're talking about. And this multi-retrieval that we discussed, it is especially designed for this. And, it takes care of tables separately with their documents and all that. So I have seen that, the approach that I discussed today, especially people use for financial documents where a lot of tabular heavy, or maybe a structured heavy kind of a documents are used.
but sir, I like that this model is very helpful when I create the model in CNN, like part CNN model, where the image processing things are happening.
Uh, I think we are little bit diversing from this CNNs. Maybe what I would request is maybe we can connect
Because
and
when
get.
I see your scripts, that is most of the inclined in the image type of data series, like that's why.
Yeah.
Yeah, Ankit, feel free to reach out offline, or yeah,
Yeah,
use the
sure,
Discord channel
sure,
also
sure.
for keeping a healthy conversation there as well. It'll be really helpful. Try and help out other questions as well. We thrive through
Thank you,
our
sir.
community, so definitely your inputs and insights will be helpful. All right, thanks Bhushan, thanks everybody, thanks for joining, thanks the leads.
Yeah. Bye for now.
Yeah, one last thing, Avinash, I saw, no, your full name. When you're submitting certificate, you'll be providing your name in that certificate link. You'll get the details in email, don't worry. You won't get your username in your certificate. All right. Thank you, everybody. Thanks
You.
for joining.
Bye.
Bye.